Every city chooses what it wants to freeze in time. Long before we had digital records, we had public monuments, conscious efforts by the community to anchor its memory into a single, unyielding physical coordinate. In the heart of the lower city, the classical bronze of Queen Victoria stands as a silent witness to generations of changing landscapes. But to truly understand the monument, you have to look past the historical name carved into the stone. You have to look at the physical reality of how it was built. From a trade and fabrication perspective, a monumental bronze statue like this isn't carved. It is engineered through a grueling multi-step industrial process called lost wax casting. The artist's initial clay form must be encased in a rigid mother mold, coated in layers of wax, packed with a dense, heat-resistant investment material, and then baked in a kiln to melt the wax out. What remains is an empty, hollow negative space. Molten bronze, heated to an incredible 2100 degrees Fahrenheit, is poured into that hollow shell. Because of the immense scale, these monuments are rarely cast in a single piece. They are poured in separate, interlocking sections. Master foundrymen then weld the sections together, grinding down the metal seams and applying a chemical acid patina to lock in a protective oxide layer. But civic monuments weren't always designed to sit completely static. In the Victorian era, the city harnessed the movement of water to celebrate public infrastructure. Fountains like the iron centerpiece of Gore Park, standing directly in the shadow of Queen Victoria, were constructed as grand symbols of municipal pride. They turned the simple utility of clean, running water into a theatrical, sculpted spectacle for the working-class public. To a trade professional, these fountains are an intense study in metallurgy and fluid dynamics. The central Gore Park fountain is constructed of heavy structural cast iron. Unlike bronze, cast iron is highly fluid when molten, allowing for incredibly intricate, ornate patterns. but it is brittle and carries zero tensile strength. The structure is built in stacking interlocking segments, sealed at the joints with lead packing to prevent pressure leaks. The true trade engineering is hidden inside the column. A central riser pipe forces water upward under high pressure to a primary manifold. To achieve the beautiful uniform cascading effect over the outer bowls without the water breaking into chaotic, sputtering sprays, engineers must utilize precision-machined brass nozzles that regulate flow velocity. At the baseline, a complex network of gravity-fed drainage lines and brass-checked valves continuously cycles the water load, managing thousands of gallons of weight without undermining the concrete foundation beneath the pooling basin. As the city transitioned into the machine age of the 20th century, sculpture broke out of the park gates and crawled directly onto the skin of our architecture. Buildings became monuments in their own right. At the old rail terminal, local artists and stone masons carved human form and historical symbols straight into the load-bearing masonry, ensuring that the daily hustle of working-class transit was framed by grand structural art. This is where fine art meets high-consequence stone masonry. Unlike freestanding statues, architectural reliefs like those at Luminous Station must function as part of the building's structural envelope. Masons utilized premium Tyndall stone Indiana limestone, chosen specifically for their uniform grain and structural density. Using hand chisels and early pneumatic tools, the carvers had to calculate the exact angle of the relief to ensure proper water shedding. If a stone carver cuts a shelf or a groove incorrectly, water will pool during a rainstorm, freeze during the winter thaw, and trigger a catastrophic spalling, literally cracking the artwork right off the face of the building. Every line was engineered to manage moisture and shadow simultaneously. old rail hubs, sculpture didn't just crawl onto the stone facades. It stepped right down into the courtyard. In Immigration Square, directly facing the historic 1931 terminal of Luna Station, standalone bronze installations stand as intimate ground-level tributes to the human pulse of survival, labor, and sacrifice. Here, the statues do not sit on soaring, untouchable pedestals. They occupy the exact same physical pavement where thousands of newcomers once stepped off trains into a completely raw industrial world. Look at the bronze figure of Mother Mary Martha von Bunning, who arrived in this city in 1852. She did not build with iron or steel. She built the human infrastructure of Hamilton, establishing orphanages to care for the children of immigrants who perished from cholera and typhoid on their voyage to a new life. Nearby, the multi-figure bronze of the Courage, Hopes, and Dreams monument mirrors that migratory journey. While the solemn lines of the Fallen Soldiers Monument ensure we never forget the laborers who dropped their tools to sacrifice everything on distant battlefields. And closer to the station steps, the portrait bust of Enrico Mancinelli honors an immigrant construction timekeeper who rose to lead the very hands that poured the concrete foundations of modern Ontario. Just steps away stands the commanding, full-scale bronze figure of Leonardo Sciascia, a tribute to the Italian-Canadian journalist and writer whose life and work served as a bridge between cultures. Erected to honor his lifelong defense of human rights and his relentless pursuit of truth through literature, the statue stands as a physical manifestation of the intellectual rigor that he brought to the public discourse. Sciascia's own background, rooted in the social realities of Sicily, mirrored the experiences of many who arrived here, making his presence in this space a testament to the enduring influence of immigrant voices on the city's civic identity. Executing standalone portrait busts and lifelike figures for a high-traffic courtyard like Immigration Square requires an exacting approach to surface metallurgy and mechanical anchoring. Because the public interacts with these pieces at close range, the sculptor cannot rely on the forced, sweeping distortions used in monumental structures, meant to be seen from afar. The fabricator must capture microscopic human textures, the intricate wrinkles of Enrico Mancinelli's expression, the fine drapes of Mother von Bunning's habit, the bronze weave of a traveler's suitcase, and the solemn weight held in the features of the fallen soldiers. To preserve these bronze surfaces against heavy urban pollution and seasonal moisture, they must be cast in premium-grade silicon bronze alloy and treated with hot chemical potassium polysulfide to lock in a stable, dark patina. The true structural engineering, however, is buried in the stone plinths. These heavy granite pedestals must be bored from beneath using industrial diamond core drills. High-tensile stainless steel threaded rods are epoxied into the stone and anchored directly into a dense concrete subbase beneath the courtyard pavers. This hidden framework resists the immense shear forces of winter frost heaves and vandalism, allowing these historical markers to remain permanently upright, integrated seamlessly into the daily foot traffic of the plaza. A bronze depiction of Leonardo Sciascia demands a similar rigor in its mechanical integration to ensure the full-scale figure remains sturdy and upright against the lateral forces of high-traffic pedestrian interaction. It is mounted using a heavy-duty internal stainless steel armature that runs through the bronze core directly into the subsurface foundation. By utilizing industrial-grade epoxy anchors set deep into the concrete sidewalk, the statue is effectively fused to the plaza's structural base, protecting it from both the mechanical vibrations of the nearby station and the persistent stress of our harsh freeze-thaw climate. At the edge of the water, where the industrial harbor meets the open sky, the monument transforms from a heavy, solid mass into a towering beacon of light. All Our Relations rises from the waterfront plaza as an immense, soaring tribute to indigenous teachings and interconnectedness. This work doesn't block out the environment with heavy bronze or stone. It uses the elements themselves, the wind, the sun, and the shifting gray storm clouds of Burlington Bay, to complete its visual story. This installation is a masterpiece of multi-material structural engineering, balancing the massive structural load of cold steel with the delicate, brittle physics of hand-blown glass. The 5 40-foot vertical frameworks were engineered and fabricated by LaFontaine Ironworks to withstand intense offshore wind loads whipping off the open water that mimic traditional indigenous beadwork on a monumental scale. Because glass is entirely rigid and susceptible to thermal shock, the internal mounting brackets must allow for minute physical tolerances, ensuring that as the massive steel frames swell in the summer heat and compress in the sub-zero winter air, the glass beads remain completely floating and uncrushed. It is a brilliant choreography of tension, weight, and transparency. As we move toward the modern era, the monument breaks free from static form entirely and begins to grapple directly with the natural elements. Overlooking the harbor basin rises Setting Sail, a striking depiction of human figures straining to control a massive sail fabricated from open pipes. It captures the eternal, gritty struggle between human labor and the invisible, raw velocity of the lake winds. Today, the relationship between art and the city has evolved into something entirely functional. It has moved onto our trailways, where infrastructure and wildlife collide. Along the historic Pipeline Trail corridor, Brandon Vickard's A Shared Trail project highlights our expanding cityscape's overlap with the natural world. By placing cast bronze native animals right on our public seating, the city forces us to stop and realize that our municipal transit corridors operate as shared routes for both humans and nature. Look at the immense mechanical fabrication required for both of these modern installations. The Setting Sail monument and the benches along the Pipeline Trail utilize heavy industrial structural piping. The pipeline benches are fabricated from Corten steel, a unique alloy designed to deliberately rust on the surface, forming a tight, stable layer of iron oxide that acts as a permanent shield against deep corrosion. For the Setting Sail monument, the engineering challenge is managing massive kinetic leverage and wind resistance. The sail structure acts as a giant lever arm against its foundation. fabricators utilized thick-walled structural steel tubing, joined together with full-penetration multi-pass arc welds to prevent structural fatigue at the stress joints. The entire monument is tied down into an immense subsurface, reinforced concrete footyard, designed to resist the constant overturning monument caused by offshore gales whipping off the bay. It is heavy industrial pipe fitting, transformed into high-stakes kinetic art. From the classical cast iron of our early downtown squares to the industrial steel pipes and luminous glass beads along our modern trailways and shorelines, the bones of this city are constantly being reshaped. These public forms prove that our streets are more than just transit routes, utility lines, and concrete blocks. They are the structural skeleton of our shared memory, built by hand, cast in fire, and erected to stand the test of time.